that again. Yeah, okay, great. So this is just like something to do with the way that JavaScript calls its value of in toString functions. You can actually do a lot of really funny other things. Like you can actually mutate. You can have actually something mutating inside a value of or toString. So over here, you can have this class mutating that actually increments a value every time you call its value of. And that leads to this really funny behavior of you can actually get this line of code working to be true. This says a is equal to 0 and a is equal to 1 and a is equal to 2. And like if you run this and we actually save, we actually get true. And that's just because value of is actually mutating this x value and then returning that. And that's just, so the point of this lesson here is try to stay with the equals in JavaScript and not the equals. Because the triple equals basically also checks for type before actually comparing them, and that gives you a much stronger comparison. Other things people complain about in JavaScript are the scoping issues and also the syntax, but these are things you sort of get used to as you sort of write in JavaScript. So thankfully there's a way to like avoid a lot of this like poor like JavaScript coding, and this is something called YesLint. And so YesLint is basically a like linting, it's a list of linting rules that you can apply to your repository. So the installation for this is actually pretty simple. You just go to the directory that you're writing your bot in, and I'm just going to quickly stash all of the things I was working on earlier. And you can do just npm install -g YesLit. Give that a minute, and while we're here, why don't we also just reinstall Battlecode in case there was a update today, which I don't think there was. npm install -g bc19. Great, so we're still on version 3.15. If you're not on this version, just remember to install right now. So from here, basically what you want to do is npm init. Basically, this creates a package. This is only just because ESLint wants you to have a package for all of your JavaScript repos. And then what you're going to run is ESLint init. And so they'll just give you a few questions about how you want to configure your ESLint. Basically, just answer questions about how you'd actually like to write. For example, the version of ECMAScript, for us, we can just write 2018. No. Your code will run mostly in a lot of these. You can just actually just take their like default answers, tabs or spaces. That's a preference thing. Double or single quotes is also a preference thing. And generally, like you want semicolons. Great. So now you have this ESLint-RC, and basically what this is a list of rules that you're going to follow. Great, and then also just going to add this extra rule, source, type, and module. And this is just saying that like all of the code we're going to be writing is going to be exportable as a module later on. Great. And so the next part is now you have a lot of rules. You can actually choose to add and subtract as many rules as you want. You can actually just go to the ESLint rules page and just see like what rules you'd like to have, and they give a small explanation of all of these. So over here, these are actual errors that YesLint can check for and actually fix some of them for yourself. And then you also have a lot of best practices. These are things that like help you avoid all the funky stuff that JavaScript does. The important one over here is equals equals equals, and this just requires that you use the triple equals instead of the double equals, which saves for a lot of really annoying things later on when you're trying to compare things and they don't end up exactly how you want them to be compared. So, and then there are a lot of other ones. These, so we can just like quickly add these. So over here, we can just do equals, 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 and then just add this rule that if we ever put in, and we'll always have an error, and we'll say always. Great, and so what this does over here is if I ever try to type a double equals instead of a triple equals, give it a minute to, the ESLint RC has an error itself. Great. So if I ever try to type something double equals over here, it'll actually just like tell me like this is bad behavior, and you can install other things to just like make it fix it by itself. So that's a pretty, this is like the most basic setup that you can have to just make sure that your JavaScript is not too risky. You can also, if you look in the Discord channel, someone's actually made a TypeScript export for this. So basically now instead of writing in plain JavaScript, you can write in TypeScript, which just enforces typing on all of your on all of your variables. And this is really great just so that like you're not just blindly sending in things. I actually do have TypeScript enabled on my JavaScript, but I'm not actually using TypeScript, so it doesn't actually give me anything useful. But if you feel that like you're having issues with you don't know what you're really sending into things, you can definitely just put in TypeScript and install it, and it's pretty quick and it's pretty portable from regular JavaScript, and you'll be able to debug a lot faster. Another nice thing about using JavaScript this year is that I think the VM actually gives you nicer looking error outputs when you actually do get an error, just because we're not transpiling it. So you don't get some archaic thing like VM. Yeah, so you won't get something like VM line 300 is not working. It'll actually tell you which function is not working. Great, so that's where we are. That's basically like how you would want to set up a JavaScript file. And we're just going to move on to doing what we did yesterday in the JavaScript. So if you remember from yesterday, we started off at the point where we have a bug nav working, and we have a bug. Basically, we can go to the enemy location and just go and attack there half of the time. And the next part of this is like we really want to show how you would communicate in this situation. So communication in Battlecode works pretty differently from previous years. So there are two types of communication. One of them is a signal, and what happens is that if you ever call this .signal inside inside your bot, this will, and you have to give it an amount of fuel and the message. Basically, you're able to send an 8-bit signal out. And what happens when you want to actually view this signal is that you're going to look at all the visible robots and see if they're radioing out something. And if they are, you can check their robot.signal, and that'll have the signal that they're radioing out. And that's only if you're within the signal radius. For us, you basically expend fuel at a 1-to-1 ratio for the signal radius squared. So if I want to reach a bot that is 2 squares away, I have to 2 squares away in one direction, I have to spend 4 fuel to get that signal all the way over to him. The other way to do this, the other way to communicate is castle talk. So if all bots have a function called castle talk, and this basically is a free 8-bit signal to the castle, to your castle. And so this works the same way. Castles can view their castle talks and see if it view all the robots' castle talks and see if anyone is sending a message to them. And from there, they can do this. This also means that because there is no signal queue and the way that signaling works this year, you can only really send one signal and one castle talk every turn. And while this can be pretty limiting on your bot, especially since you're only sending 8-bit messages, you can also choose to make communication protocols that span over multiple turns, like we did yesterday. So that's what we're going to do today. So today what we're going to do is basically we want to be able to tell when we get a new robot, and the enemy has robots. So basically, if you have a scout at the beginning of the game and they rush over and see that they're building a lot of castles, a lot of Crusaders, prophets, and preachers, and it's important to keep track of like what kind of bots the enemy team is making. But basically what we want to do is be able to have the castles as our headquarters, be able to sort of keep track of what sort of bots are being created. So that's where we're starting today. So we're going to start working in the Crusader code. So in the Crusader, we start by looking at all the visible robots. And then var self equals this, and then attackable basically goes through and sees if there's anything in our attackable radius. So we're going to start from here. So through the visible robots, we're going to basically just iterate them. For let I is equal to 0, I is less than visible dot length, and I++, we're just going to look at each robot. Const robot is equal to visible I. And for right now, what we're going to do, oh, and this is just an error just because we're not using it yet. It catches a lot of really nice things. So what we're going to do is basically, if it's a enemy castle, we should let our castles know where the enemy castles are. So what we're going to do is const robot is equal to visible I, and then if the robot dot team is not equal to me dot this dot me dot team, and starting parentheses, and robot dot unit is equal to specs dot castle, what we're going to do is first self dot log enemy castle found, great, and it looks like we've already started catching things like this single or double equals instead of a single equals. Enemy castle found. And so now we want to transmit this message back to our castle. And so because we have this like really nice castle talk, and usually by the time we get to the enemy castle, we're not in range to make a reasonable message to our original castle in using the regular signal. The fuel cost would just be too much. So we only have 8 bits, and the communication for a single coordinate is, because we have it, because our coordinate system can go up to 64, which is 2 to the 6, we are actually not able to send the full coordinate in one go. So instead, we'll just send in 1 and then let the next one have the next one go. So what we're going to do is this dot pending message is equal to y. And we're going to just self.castleTalk the first part of our message. And so we're just going to say self.castleTalk x. So because we don't want to actually have like multiple signals going at one time, if we castle talk again in the same turn, basically we're overriding our first one. So what we're going to do is just surround this with a if this dot pending message. Great. So if we have a pending message, we should send that first. And so we always send the x value and then the y value. Else we're going to self.castleTalk the pending message, this dot pending message, and then set that to null. Self this and this dot pending message is now equal to null. Great. And so what this is going to do is that we're going to send a message back to our castles about where our enemy castles are. So that's fine and dandy for the Crusader, and now that's all you need to do to send a message. Now let's get to the part of receiving a message. So this is the part where we have a castle. So over here, what we're going to do is, again, we're going to look for all the visible robots. Great. And then we're going to look for all the messages is equal to messaging robots is equal to visible dot filter. And so we're going to take in a robot and just see if it has a we're going to just check if it has a message that it's actually sending to us. So we're going to filter out if the robot does not have a castle talk. Great. And let me just quickly check the documentation to make sure that this is correct. So over here, what we want to do is that this is the castle. So this is the castle talk where castle messages are actually being sent to. It's a little bit interesting because like this one goes back into not camel case. So now that we have all of our messaging robots, what we're going to do is create, and so the same thing over here, because we have pending messages, on one side, we have to also consider pending messages on our side. So what we're going to do is create a this dot. So what we're going to do in our constructor is we're just going to quickly add this dot pending received messages. Pending received messages is equal to an empty dictionary. Great. And we're also just going to quickly call super. Great. So now that we have all of our messaging robots, so what we're going to do is if messaging, and also quickly add over here this dot enemy castles is a list. And so we're just going to keep all of our enemy castles in a list. So if the messaging, if pending received messages, if this is the first message, basically we don't have a pending received message from this robot. Okay, great. 1 second. Const. So let's get this on a for loop. Let I equals 0. I is less than messaging robots dot length and I plus plus. And so if we don't have a message from this robot, we're going to add it to our pending messages because they've only sent us half of our message so far. Great. So if pending received messages robot.id, if we don't have one, basically let's add this message. So pending receive this dot pending received messages robots.id is equal to robots.castletalk. Great. Else, now we've received the full message, what we want to do is append this robot, append this enemy castle to our list of enemy castles. So over here, what we're going to do is this dot enemy castles dot push, and we're going to push an object that represents the coordinates. So the x value is the first message, so this dot pending received messages robots.id, and then the y is the new message. Great. And these are parentheses. Great. And then we'll just clear out this dot pending received messages robot ID is equal to null. Just clear out that field so that if it tries to send us new information, we're not just going to ignore it. Great. And then every 100 steps, let's just print out what we have as the enemy castles. This dot log known enemy castles. For let I equals 0, I is less than this dot enemy castles dot length I plus plus this dot log, and then we're just going to print out this dot const x y from this enemy castle. Great. And change this to a single quotation. All right, excellent. And let's see what happens when we run this code. All right, so it looks like we haven't found any enemy castles. That's all right. Let's try running this again. Great. Reference error, why is not defined? Oh, yes. This .pending message is equal to robots.y, and this .pending castle talk is robot.x. Great. All right. Great. It looks like we're getting all the enemy castles, and this is excellent. Just one issue is that we're sending the enemy castles multiple times, so let's just get rid of that. So if so what we're going to do is over here, also this dot, we can reuse enemy castles over here, and we're just going to push robots.x times 64 plus robots.y. And over here, we're just going to check that we are not going to repeat the same robot. And this dot enemy castles dot index of, and we're going to check that this thing over here is not repeated. Index of returns -1 if it's not found, so we're going to check that this index of is less than 0. Great. All right, excellent. So we see that we said that over here that the known enemy castles, it looks like two Crusaders founded at the same time, so they both told our castles. But this is great. Basically, what we're doing now is that we can actually get a message from one point to the other, and basically, if you're able to communicate with your units, this provides a lot more flexibility in your strategies. Are there any questions? Are there questions on Twitch?
Let's see.
Yeah.
So, before I thought there was a way to send a 16-bit message.
There was a way to send a 16-bit message.
Is there not?
So I think they're used. I don't know if the specs changed about this. So basically, you have two ways to send an 8-bit message. And one of them requires no fuel at all, and the other one requires fuel proportional to the radius squared of the signal you're trying to send. So if you're trying to send something to someone far away, it's basically you have to spend a lot of fuel to yell that message out. So if you're actually in range to do both of them, then you effectively have a 16-bit message. But otherwise, I don't know if our specs changed from the very beginning, but that's all we have. Yes. Oh, I'm sorry. Go ahead.
Also, how do your castles communicate? Do they communicate just as the same as that? So like radius and also directly to the 3?
Yeah. So castles have both signal and castle talk. You have to make sure not to read your own castle talk. But yeah, they have the signal thing that depends on how much fuel that they have that they can spend.
For their castle talk, do you have to know the location of the spot or anything like that, or just you need to know the ID?
So the only things when you're messaging something and it's not within your visible range, the only thing that you know about it is its ID and what message it sent, and I think also whether or not it's messaging. So all the other information is hidden from you, like the health, where it's actually at, what team it's on. Those are all not known. Does that help?
Yeah, and so if castles can directly communicate to a single unit, right?
Yeah, they can. Or they can't only signal you. They'll signal everyone in the radius between you and them, but they can signal other units.
And that would cost fuel, right?
Yeah. Basically, you get this one big signal, and it costs the fuel. Great. Did you have a question?
So I was just going to say that the documentation still says that radioing can do 16-bit.
Oh. Oh, no.
Yeah, I think people are confused about that.
Is radioing 16-bit?
Oh, also,
Oh, I'm sorry.
yeah, I heard it was 16.
Oh, okay, I'm sorry. Yeah, I think radioing is 16-bit. Apologies for not saying that. And only the castle talk is 8-bit.
The chat has a question about if you shout a message, can it only reach the robots who haven't taken a turn so far?
If you have, so I think your radio is actually, I don't want, I'm just going to quickly just check the documentation on this, but I believe that the radio gets wiped out at the end of every round, which means that if you start earlier in the turn, you can't see it. Let me just quickly check this. Castle talk. Communication. Great, it's not in our documentation. I'd like to say that like it gets kept until the next signal is sent, but that's probably also very wrong.
Should I just say like
Yeah.
indeterminate for now?
Yeah, this is, we'll determine this after this lecture. This is actually the end of today's lecture, so because we were just trying to repeat what we were doing yesterday. So we're going to just go back and ask the other devs what they think of what the current state of communication is. Thank you. Are there any other questions? Great. We'll make an announcement once we clarify how exactly communication works, and we'll let everyone else, yeah, basically through the Discord, we'll let everyone else know. Are there questions on Twitch?
That was the only question.
Okay, great.
Let me just